Question 10. So I think the marks are quite skewed here. I really think part A is the hardest bit. So we've got to show the volume equals something given that the surface area equals 800. Now a surface area of a cylinder is as if you're wrapping it up in paper. It's covering all the sides. So we've got the circle at the top, the circle at the bottom, and the curvy bit, which if you unwrapped this curvy bit, you've got the circumference, a rectangle, which is really the circumference times the height, so 2 pi RH. So that is the surface area of a cylinder, those three sides together, and together we're told they equal 800. So gathering up our terms and rearranging to make H the subject, we get H being this. Now we know a volume of a cylinder, a volume of a prism is just the area of the end bit times how deep it is, so pi r squared times H. So substituting in what we know H being this, so replacing this H with this, we get this, which only has an unknown of r. So tidying up, so cancelling out the pi and one of the r's, pi and one of the r's, we get v equaling this. Just dividing both of these terms within the bracket by 2, we get r times this. Multiplying by r, we get this, which is what we had to show. Now for part B, to use calculus to find the maximum value of v, so we have to differentiate. We differentiate v with respect to r. So we differentiate this, which gives us this. Now at a maximum or a minimum, the differential equals 0, so this has to equal 0. So we rearrange to work out that the radius is 6.515 approximately. Now that's the radius, we want the volume. Well, we know volume equals this. So we've just worked out what the radius is, so we substitute the radius in the 6.515 into this to work out the volume, which I've done here, which to the nearest centimetre cubed is 1737. Now for part C, we take the second differential. We work out d2v dr squared, so we differentiate this. When you differentiate this, the constant goes, we multiply by 2, so we get minus 6 pi, reduce the power by 1, minus 6 pi r. Now r is positive, 6.515, so we can see that this term is going to be less than 0, it's going to be negative, therefore that shows and justifies that V is a maximum volume.